Hello everyone, today we will be exercising our skill in trigonometric substitution. So today we have the integral of 1 over 4 plus 4x squared plus x to the 4th dx. So this can't be solved with regular integration skills, so we must use trigonometric substitution. So to begin, let's recognize that we can rewrite this as 1 over 2 plus x squared dx, and that's just factoring. So from here we have to set up our trigonometric triangle, and so we can find our x and our dx for our substitutions. From our triangle, we got that x equals square root of 2 tangent theta, and dx equals square root of 2 secant squared theta d theta. Now we'll use x and dx to make our substitution. So we have the integral of dx, which is root 2 secant squared theta d theta, over, and then we have 2 plus x, well our x is root 2 tangent theta, and our x is squared, and our entire denominator is squared. So now we can reduce this. So let's pull out this root 2 out in front. We have root 2 integral secant squared theta d theta over, and then we'll simplify this part first. So we'll carry out this operation. 2 plus 2 tangent squared theta, and then this is squared, our denominator. So from here we can we can pull out a 2 from this denominator, and we're left with 1 plus tangent squared theta, which is equivalent to secant squared theta. So we still have our denominator squared, so to get rid of the square we can just make this 4 secant 4 theta. So we're getting closer to our answer. Now we'll pull out this 4 out in front, and we're left with secant squared theta over secant 4 theta, and which reduces to 1 over secant squared theta, and that's the same thing as cosine squared theta. So just pulling this 4 out in front, we're left with 1 over secant squared, or cosine squared theta d theta. And before we take the integral, we can use our power reduction formula to reduce this. So this is equal to square root of 2, 4, and that is just 1 plus cosine 2 theta over 2 d theta. And then we'll pull this 2 out in front. So we have square root of 2 over 8, so 4 times 2 is 8. Integral of 1 plus cosine 2 theta d theta. So when we integrate this, we have 1 becomes theta because we're integrating with respect to theta. So theta, and cosine 2 theta simply becomes sine to theta over 2. To simplify this further, I have summoned our trig triangle here. So we must use our x and our theta here. So for theta, we find theta by using x equals square root of 2 tangent theta. So we'll isolate tangent theta, and then we'll just take the inverse inverse tangent. So tangent or theta equals tangent inverse of x over square root of 2. So we can use theta to make our substitution here. Now for our sine 2 theta, we must reduce it. So sine 2 theta is the same as 2 sine theta cosine theta. And then we still have our denominator of 2. And as you can see, these two cancel. So we must find sine theta and cosine theta. Square root of 2 over 8. Inverse tangent x over square root of 2 plus our sine theta opposite over hypotenuse. And that's multiplied by cosine of theta. Well, cosine of theta is adjacent over hypotenuse. So square root of 2 over square root of 2 plus x squared. And if we simplify this, our denominators cancel, or the square roots cancel. Square root times square root is simply the inside. So we have square root of 2 over 8 x squared. And then we can pull out a root 2 factor out of each term. So if you pull out a root 2 factor, x squared. And we can reduce this to 1/4